AI feels like it arrived suddenly. One day we're reading about it in science fiction, the next day it's writing our emails. But the field of artificial intelligence is actually almost 70 years old. Understanding that history helps explain both why progress felt slow for so long and why it's accelerating now. The story begins in 1956 at a summer workshop at Dartmouth College. A group of researchers coined the term artificial intelligence and made a bold prediction. Within a generation, machines would be able to do anything a human mind could do. They were brilliant, and they were wildly optimistic. What followed was decades of cycles, periods of excitement and funding, followed by disappointment and withdrawal. These downturns became known as AI winters. The first winter came in the 1970s, when early promises didn't materialize. The second came in the late 1980s, when a technology called expert systems, essentially encoding human knowledge into rules, hit its limits. Billions of dollars were invested and, by many measures, wasted. So what changed? Why does this current wave feel different from the ones that came before? Three things came together. First, computing power. The algorithms that drive modern AI, particularly deep learning, require enormous amounts of computation. In the late 1980s, training a serious neural network might take months or be simply impossible. Today, thanks to advances in processors, especially GPUs, which were originally designed for video games, we can train models in hours or days that would have taken years before. And cloud computing means you don't need to own a supercomputer. You can rent one by the hour. Second, data. Modern AI systems learn from examples, millions, sometimes billions of them. The internet created an unprecedented ocean of data. Every photo uploaded, every document written, every transaction recorded became potential training material. Without this data, even the best algorithms would have nothing to learn from. Third, the algorithms finally had room to work. Here's where there's a common misconception. The core techniques behind modern AI aren't new discoveries. Neural networks were conceptualized in 1943. The perceptron, an early learning machine, was built in 1957. Backpropagation, the training method that makes deep learning possible, was published in 1970. Researchers have understood these ideas for decades. What changed wasn't the mathematics, it was the ability to run these algorithms at meaningful scale. Early researchers couldn't train large neural networks because the computing power didn't exist. They couldn't feed them enough data because the data didn't exist. The ideas were there, waiting. The one genuinely recent innovation is the transformer architecture, introduced in 2017. This is the structure that makes large language models like ChatGPT possible. It was a real breakthrough in how models process sequences of text. But even this built on foundations laid decades earlier. These three factors, computational power, data, and the ability to finally scale proven algorithms, created a moment where old ideas suddenly worked at levels no one had seen before. The result was a series of landmark moments. In 2012, a deep learning system dramatically outperformed traditional approaches in image recognition. In 2016, an AI system beat the world champion at Go, a game many thought would take decades more to crack. In 2017, researchers introduced the transformer architecture, which became the foundation for large language models. And in late 2022, ChatGPT brought these capabilities to the public in a way that was suddenly, undeniably useful. Now, why does this history matter for you as a leader? For a few reasons. First, it explains why skepticism about AI is reasonable. This field has overpromised before, repeatedly. The pattern of hype followed by disappointment is well documented. Anyone who tells you to ignore that history isn't being honest with you. But the history also explains why the current capabilities are real. We're not riding on hype alone. We're seeing what happens when decades-old algorithms finally get the compute power and data they always needed. The question isn't whether these tools can do impressive things. They demonstrably can. The question is whether they can do useful things in your specific context. Second, it helps you understand the pace of change. The improvements we've seen are significant, but they're not magic. They're the result of scaling, bigger models, more data, more computational power. That scaling continues, which means capabilities will keep improving. But it also means the fundamental limitations we'll discuss, hallucinations, bias, the need for human oversight, aren't going away anytime soon. They're futures of the approach, not bugs being fixed next quarter. And third, it frames your strategic window. Many organizations are building AI capabilities now. Some will get real value. Others will waste significant resources on poorly conceived projects. The difference usually comes down to whether leaders approach this with clear thinking or got swept up in the pressure to not fall behind. The goal of this course is to help you be in the first group. In the next lecture, we'll go one level deeper and look at machine learning, the engine that powers most of what we call AI today.